Alright, what's up everybody? My name is Sunny. I've been a business analyst for about 3 weeks. Today I'm going to teach you how to make tables. And we're going to walk through tables and it's a little bit of something you should know before you jump into SQL. So, what's up Sonny? I'm recording right now. Oh. Anyway, so a table basically is going to be comprised of three kind of main elements. One is the value that's inside the table. We'll say for now like the value is red. And then you have a column that's in the table. So we'll say, so the column, and then we'll say this is car color. And then we have a table called, I don't know, like customer cars, right? So you have customer cars, that's the table name. So you have a bunch of values within a column. So you can have multiple records. Each record can be different values. You know, if you have a red car, yellow car, blue car, you'll represent that with a value. The column is always going to be constrained by the type of value that's in there, and then you're going to have, you know, that column, a group of columns is going to have be called a table. Now, there's some rules that a table should always have. See, the thing is, tables and spreadsheets get really close to each other, but in a database, a few things that a table should have. So requirements for tables. Generally, a table is going to have a primary key. Now, a primary key is unique throughout the table, meaning it doesn't repeat. And you need a primary key to basically unambiguously identify a record within a table. And then besides that, you're going to basically have columns within a table. That's defined up here. And then you don't necessarily need to have records. That's not, you can have a table with no records, and that's still a table. Okay, so this is some high level stuff. I might come back and add some more stuff here. I wanted to talk about some, like, let's build a table, for example. Okay, so suppose you have customers over here. We call this customer cars, right? Suppose you have Sunny has a red Toyota and he lives in Buena Park. Okay, then you have Nahar that has a blue Tesla and lives in Dublin right now, right? Then you have Joe who has a green Toyota as well, and he lives in Cyprus. Okay. Now, this is just a basic table. And in order for this to be a table, of course, we'll have to have a primary key. Right now, there's no primary key. And what you do, so this is name, this is color, this is type of car, and this is city within our thing. So I'm just going to add a random primary key. That generally how primary keys are made. They're just randomly assigned, computer generated IDs. So this is now a table. Okay, I can convert it into an official table here, but that doesn't matter. Okay, now suppose you have this table, but you have millions of records, and you have the word Toyota that pops up a bunch of times within that table. So suppose Toyota for some reason changed their name to Toyota, right? They put a Y at the end. If that was the case, then you would have to update Toyota to Toyota, I mean countless of times in your table. So right now, the way this table sits, it's what's called denormalized, meaning everything is in one big table. Tables that are like databases that are intelligently designed are going to be normalized. This is denormalized right now. Let's normalize this table. Now, the type of elements we have in here, we see customers, that's one kind of type. Then we have cars here, and then we have locations here. So now what we can do is create this table into these three different tables. So this is, we'll call this denormalized. this one here, okay? We'll call it right here. So this is the denormalized table. Okay, I'm gonna make the same table, same data that I'm representing with these three records. I'm gonna create a normalized version of it. So this is normalized. So first what we do is create the customer table. So in our customers we have Sunny, Nahar, and Joe. Okay, so Sunny, Nahar, and Joe are here, and we're gonna give them a cust ID. So we'll see, we'll say C1. So Sunny is now C1, C2, and C3. This is now a customer table. Then we have a cars table, right? So cars, we have so far two cars. We have a red Toyota, we have a blue Tesla, and then we have a green Toyota, right? And we'll call this one, we already use customer, so we'll call it CR1. And this one we'll call it CS1, just to make it consistent naming standards. So now we have two of our three tables, and then lastly we need a location table. And in our locations we have essentially three locations. So we'll call this L1, L2. Now this data is normalized, and right now we know Sunny has a red Toyota in Buena Park. But in this table, we just know there's Sunny, we just know there's a red Toyota, and we just know that there's Buena Park. So what you're gonna have to basically marry this data up is something called an intersection table. This is a concept that they use in basically like data warehousing. But an intersection table is going to assign these three guys. So what this will say is cust ID here, and this will say, or actually let's call it CS ID, CR ID, and L ID. So a location ID, or sorry, a customer ID, a car ID, and a location ID. And by now I'm sure logically it's kind of already making sense. So to represent the first, well actually you also need the primary key, so we know kind of how to map it back to this denormalized version. So we call this key, which is the same column here. So to represent, you know, record number one, which is Sunny Red Toyota at Buena Park, you would say Sunny is CS1, and then you can say Sunny is CS1 with a CR1 with an L1. And this lets us know that Sunny has a red Toyota in Buena Park. Now, another reason normalized database structures are more intelligent is suppose this red Toyota, right? Suppose another person named Mike also has the red Toyota, and it's the same exact one, right? But he lives in Brea, okay? Now, with the structure, you can't, there's no ID on this red Toyota. So, having the red Toyota as one object here will let you assign that red Toyota multiple places here. So when it's in this structure, you kind of lose that information. When you have it in a normalized structure, which is, separate tables for each entity type and an intersection. Let's also actually finish out 2, 3, no, 2, where did they go? 1, 2, 3, 4 here. And we put the same numbers here. So this is CS2, CR2, L2. And actually, I think we can just drag this. Yeah, except Mike, number 4, is customer number. Well, we actually haven't assigned him. Let's go ahead and assign him. So this is CS4. His name is Mike. and he lives in L4, which is Brea. So he has the only difference between record 1 and 4. They both have CR1, which is that red Toyota, but they're different customers and they're in different locations. Locations, of course. So another good thing about normalizing is in this table we may only want a location ID, but you can elaborate on the location in the location table, like the city, the zip, the coordinates, right? Excuse me. So you can elaborate on location data in the location table, but that's not necessarily in your intersection table. When you have a denormalized data structure, those additional elements, you'll choose basically not to capture them because you're unnecessarily taking up space. And also in a denormalized, like when you receive denormalized files, they're generally go with like hundreds of columns to the right and thousands or millions of columns down. And having that in a single file or in a single table just makes it very inefficient to query, inefficient to transfer, and whatnot. So, there's normalized versus denormalized. You're going to have these primary keys in all of these tables. And then what you can start doing next is using SQL to combine these keys and pull the data in specific ways that you want. So, yep. Cheers.